All right, guys. So, final video of the chapter. We're going to look at something that is a little bit more complex, but it is used a lot in future math classes, especially Algebra 2 and beyond. So, really, if you're going on to take more math classes in college, anything STEM based, you're pretty much going to use radians from here on out. And some of you have already seen radians a little bit with our trig chapter. Remember, we had to make sure that we were in degrees and not radians. Well, now we're going to get a little exposure and figure out what the heck these radian things actually are. So what I want you to do is to think about how many times this radius would fit around the circle. So if you have a way of trying to do that on your own, feel free to pause and work it out. But I'm going to show you my method here in just a couple seconds. So what I suggest doing, if you take a little piece of string right there, it's about the same size as the radius, and then you can lay it around the circle and see how many times it goes around. So there's one, and then I can just move it on down. 2. 3. 4. 6. And just a little bit extra there. All right, so the general idea is about 1, 2, 3, 4, 5, 6, and some change. Hey, guess what? Maybe some of you really, really clever ones out there thought, I already know about the distance around a circle. It's 2 times pi times radius. So when you ask me how many times that radius goes around the circle, I already know it's exactly 2 pi. What? Yeah. Oh, man, he's so smart. You'd be exactly correct, though. That little extra bit right there is the little bit on pi that goes on forever, right? Pi, our decimal, is 3.1415. I forget it. But the first number, the whole number, is 3. Well, if we double that, hey, we get 6. That little decimal part, 0.28 or so, is that little extra part that's right there. A radius fits around a circle exactly 2 pi times. Unfortunately, that pi is an infinite number, so it's really hard for us to visualize what that means, but it's just a little bit over 6 because pi is a little bit over 3, and 2 of that would be just a little over 6. So I guess the way to write this would be that any circle radius fits around the circle. 2 pi times would be the answer to the question up there, figuring that out. And remember that 2 pi just is a number. It's just an infinite number. Just like if I said, the days of the week is 7. 7 is the answer. 2 pi is the number that is the answer. It's just an infinite answer. We can't write all those infinite decimals out. So we use that pi symbol, which is what radians gets into, is that when we work with degrees, you very often run into decimals. And actually a bigger issue with degrees is the fact that, have you ever wondered why there are 360 degrees in a circle? Like, who decided how big a degree would be? Who was like, that's the right size. Yes, let's make 360 of them fit in there. Yes, that's what it is. Like, why? Well, I mean, why kind of actually has an answer is because, that's what they thought days in a year. We have 365 now, which still isn't exactly right. But it's really, really close. And 360 is what, when people were working with geometry or figuring out geometry for the first time, they thought there were 360 days. And so they thought, hey, that makes sense. Let's make each day a degree, basically, right? That's the only, if we lived on Mars instead of Earth, there'd be more days in a year and there'd be more degrees in a circle. But it's just because we live here. So in the math world, that's not really neat, right? You're introducing this number that doesn't really have a reason other than how far Earth is from the sun. That's going to be kind of problematic. So this idea of using the radius or the relationship between the radius and a circle circumference to be able to measure a degree. So like this right here, this angle that I just drew would be called 1 radian. This is 1 radian. Because instead of saying it's 30 degrees, and again bringing in this idea of a degree that doesn't really have any serious meaning, we can relate that back to itself. So you're talking about how far around the circle it is using a unit of the circle to measure the circle. You're using the circle to measure itself, right? It keeps more advanced math simpler, believe it or not. Makes things reduce well and simplify. Anyways, a radian, it's just it's when an arc length is equal to 1 radius. Maybe it's worth saying too, it's like a more technical way to measure angles. I'm put technical in quotes because I don't know. I just made that up. So, anyways, that's what a radian is. It is, instead of saying like this is 45 degrees or something like that, it's 1 radian. It's 1 radius around the circle. It's what the idea of a radian is. And every circle has exactly 2 pi radians in it. So you can go around the circle. To go all the way around the circle, you need 2 pi radians, just the way that you needed 360 degrees. Right? Those things are equivalent. 2 pi radian is equal to 360 degrees. Those are the same thing because it takes 2 pi radiuses to go around. It takes 360 degrees to go around. Okay. So in fact, the way that we actually convert from degrees to radians is if you have a degree, you're going to multiply that by pi over 180 to get a radian. And if you have a radian, you're going to multiply that by 180 over pi to get the degree. In this case, you're introducing the pi, you're multiplying by pi, and all radians are in units of pi, or in multiples of pi, I should say. Whereas here, you're dividing out the pi, and the 180 comes from the fact that there's 2 pi radians in 360. If we divide that 2 across, that's where you would see pi radians equals 180. So the 180 comes in from the fact that there are 2 pi radians in 360 degrees. So we divide that 360 by 2 is where the 180 comes in from. So if you have degrees, you're going to divide by 180 and put a pi on it to get radians. If you have a radian, you're going to divide off the pi, get rid of the pi unit, and multiply it by 180 to get back into degrees. It's kind of the conversion. So let's look at how some of that works. First couple, I have degrees, and I'm going to radians. So I'm going to be using this part right here. So I take my degree, 30 degrees, I'm going to multiply it by pi over 180. Well, in practice, what that's going to do is you're going to take the number and divide it by the 180. So 30 divided by 180, but we always want to keep fractions here. We never work with decimal pies because, again, pi is already an irrational decimal that goes on forever. I don't want to have a decimal amount of an infinite decimal. That's just crazy. So when I say crazy, it just doesn't stay neat. Like the whole idea of working in radians is to get exact values. So when I do 30 divided by 180, if I get a repeating decimal like that, I have to switch it back to a fraction, 1/6. So I have 1/6 pi, or the way you'll normally see that written is you put the pi in the numerator. The pi goes in the numerator. So I'll just have 1 pi, or pi over 6, because multiplying something by 1 doesn't do anything. So I have 30 degrees is pi over 6 radians. 120 degrees. Actually, see if you can go ahead and do the next two. I know this is confusing, guys. Like, this is a whole new idea. It's reintroduced again. You'll work on it more in Algebra 2, like a whole chapter in Algebra 2 just on radians. And then it's just assumed that you know how to use it from there on out. And it's used constantly in pre-calc and calc and any higher level math, physics, calculus-based physics. Everything uses radians. So like some of your calculators even default to radians because it's just what is used when you get beyond high school for sure. Like degrees are easier for you to understand when you're young, but again, we kind of phase them out around this point in your math career because they're not very accurate. Well, they're just messy. The degrees are just kind of messy. Radians work better. It's the best way to say it mathematically. So try to get your head wrapped around it. If nothing else, try to make sure you understand this conversion. Do the next two problems where you're going to divide by 180 and put a pi with it, and that'll switch you from degrees into radians. So go ahead and pause and try that now. All right, so I took the 120, divided it by 180, and when I do that, again, I'm getting a repeating decimal. If your calculator has that math frac button or a way of switching between repeating decimals and fractions, it's really handy. Otherwise, you've got to sit here and figure out how to reduce 120 over 180. Like you can divide them both by 10. So then I've got 12 over 18. Well, then I can divide those both by 6. So then I get wow. 12 over 18. If I divide those both by 6, then I'll get 2/3, which is where I was trying to get to anyways. So that 2/3 pi, right, is 2 pi over 3. You put the pi with the numerator. Again, it gets complicated if you don't have a way of doing that. I know it's a little tricky. Oops. 270 divided by 180 on the next one. You get 1.5, but don't write the decimal in there. We're not going to multiply an infinite decimal by another decimal. Right? You're going to switch that into its fraction, which 1.5 is 3/2, 3 seconds. So 3 pi over 2. Which again, if you don't have a calculator that does that, you can get rid of the zeros. Dividing them both by 10 would leave you 27 over 18. You can divide those both by 9, which would get you to 3 over 2. Would be the way to get there if you don't have a calculator that reduces it for you. So it's a little tedious, but it is what it is. Pi over 18. Now I'm switching from radians into degrees. So I'm going to use the second version where I multiply by 180 and divide by pi. Well, this part's kind of nice, pi over 18. Multiply by 180 and divide by pi. The dividing by pi just cancels your pi unit because degrees don't typically have pi units in them. So it cancels the pi off, and now I just have the numbers left over. 180 divided by 18. Something in the denominator is dividing. Or another way of saying it is 1 over 18 times 180. I'm going to have this is going to be dividing at some point. You know, if you multiply it across, you get 180 over 18, and then you're dividing. However you look at it, things in the bottom are going to be dividing, things at the top are going to be multiplying. So I've got 180 being divided by 18. Hopefully you don't have to do this in the calculator, but it is 10 degrees. So 10-degree angle. A 10-degree angle is pi over 18 radians. Those are the same thing. Hey, this one should look familiar. 3 pi over 2. Hey, we already did that guy. 3 pi over 2 times 180 over pi. Well, the pi just cancels. Now I have 180 times 3 divided by 2. Or you can do that in reverse, 180 divided by 2 times 3. Either way works. So I'll do 180 times 3 divided by 2, 270, which is what we were supposed to get there. 270 degrees. Go ahead and pause and see if you can work out the last one on your own. Hopefully that wasn't too tricky. Cancel the pi. 180 divided by 4 gives you 45 degrees. So that is the conversion stuff. Again, I know this is confusing. You will have many more times to learn this down the road, but it's just introducing it this year. It's only one part of your chapter. It's not a whole chapter like it will be next year. So put in some work working on this, but don't get too frustrated if you're struggling to understand it as a new way of measuring. Here is another place that it kind of pays off is when we were looking for arc length. Before, remember, we had to find what part of 360 this angle was, and then we had to find the circumference and it was kind of tedious. But when you're going to when you're working with radians, right, this number is how many radiuses the arc length is. So all you have to do to find a what do you call that? Forgot the word. Subtended. Sorry, subtended just means part that goes between 2 points. Would be the easiest way to say it. So to find this arc length, another way of talking about it, to find that arc length, you just take the radian. So the angle in the central angle is in radians. You take the angle measure times the radius. That's it. To find an arc length, you just now need to multiply the radian measure times the radius. Let me show you how that works down here with actual numbers. So if the central angle is pi over 4 radians and its radius is 2 centimeters, determine that arc length or that subtended arc. So arc between 2 points. On a circle. Just a little vocab in case you see that anywhere else. So that arc length is going to be equal to the radian angle, pi over 4, times the radius, times 2. Well, that's 2 pi over 4, which reduces to 1/2, or just pi over 2. So if we knew what pi was, like the whole number, you knew the whole number, all the way to the last digit, and you divided it by 2, that's how long that arc length would be. But again, almost everything that involves circles is an infinite number because it all revolves around pi, and we don't know all that. So a lot of our answers are going to feel like this. It's kind of dissatisfying until you get used to like this being just another number like 7. It's just an infinitely long number. So we leave it in this pi-based form. What is the measure in radians of the central angle? Well, the same idea holds that the arc length is going to be the angle times your radius. As long as that angle is measured in radians, all I have to do is say, okay, well, your arc length here is 15. Cool. Oh, your radius is 3. Double cool. To find that, just divide. Right, so this is what I mean by the math works better in radians. Like things just take care of themselves. You get stuff that cancels out. Things are proportional to one another. 5 radians. Right, it's not degrees. It's not just like it's not 5 centimeters. It is 5 radiuses. This measure around. For some reason, this doesn't have pi in it. That's weird. But normally they would involve pi. Almost always the arc length involves pi. It's kind of annoying or weird that they didn't put it on that problem. But anyways, that's all there is. Like this makes a simple, easy relationship between radiuses and arc lengths because we're measuring the angle in terms of radiuses. So it makes the relationship really, really easy. An arc subtends or goes around a central angle, meaning measuring 7 pi over 4 radians. So this measurement, right? 8 pi over 4 would be 2 pi. That's a full circle. So this is just a little less than a full circle. And it's telling us the radius is 6. And it wants to know what the arc length is. So again, that arc length, just call it A this time. You take the 7 pi over 4, you multiply it by the radius. It's going to be a pretty gross answer. 6 times 7 is 42. This feels like a Khan Academy problem. Like just annoyingly, numbers that don't work well together. You can divide that by 2, so at least get it down to 21 pi over 2. But you would leave it there. Because to go any further means you're going to introduce decimals. Either you get 7.5 if you divide, what's 21 divided by 2? 10.5. Or you type in pi in a calculator and you get an infinite decimal. So this would be the simplest exact answer. That arc length is going to be 21 pi over 2. And we can do the same thing, not just with arc lengths, but with sectors, because the area of a circle also involves the unit pi. So a sector has a radius of 9. So the circle's radius is 9 centimeters, and the area is 54 pi centimeters squared. So if we did 54 times pi, we would get a decimal approximation for how much area is in here. But we leave it as 54 pi so that we have the exact value. It wants to know what's the central angle in radians. So what is that measurement right there? Well, it's got to be somewhere between 1 pi and 2 pi, because 1 pi would be 180 degrees. halfway around. 2 pi would be all the way around. So somewhere in between 1 and 2 should be the fraction that goes with the pi. And to figure it out, we could take, let's see, the area is pi r squared. And I know my radius is 91. I'm sorry, 91, 9, and I'm squaring it to get 81. So if I have pi times 9 squared, it's going to give me 81 pi is the exact area of this circle. I have 54 pi out of the 81 pi. So that tells me I have those cancel. I don't know if this is the easiest way to do this problem, but we're already here, so. So we've divided those two, 54 divided by 81. The pi's canceled because I'm dividing them by themselves. I get a repeating decimal, so I switched it back over to 2/3. So I have 2/3 of the circle, and 2/3 of 2 pi would be 4 pi over 3. Because 2 pi is the full distance around. I have 2/3 of the area, so that means I'm 2/3 of the way around. 2/3 times 2 pi would be 4 pi over 3. 4 pi over 3. 3 pi over 3 would be 1, and 6 pi over 3 would be 2. Again, remember I said it has to be between 1 and 2, because 1 pi would be 180, 2 pi would be all the way. So this is in between 1 pi and 2 pi. All right, guys, I know it's confusing. It is a whole new way of measuring angles. It seems wildly unnecessary. It's a new thing that is better for higher level math if you're not going to take anything after Algebra 2. At the very least, you'll see it again in Algebra 2 next year. So spend some time trying to get familiar with it, put in some work. And again, if you're going to go on to higher level math, make sure that you kind of have an understanding of what radians are and how they work a little bit. And really, if you have questions, this is a great time to ask, because this stuff's not going away. It'll be in every math class you take from here on out. So put in some practice. Let me know if you need help.